We're gonna do an instructional video on the concept of dark energy. What is dark energy and why did it come about this concept? It's using cosmology in the theory of the Big Bang to explain something mysterious that is happening, which is that we found recently that the universe is expanding faster and faster with time. It means that now the galaxies are flying away from each other much faster than it was in the past. And how do we know that was so? Because we can see 1A supernovae, that is explosions of stars that are very, very, very far away, sometimes 8, 9, 10 billion years, light years. And in relativity and in cosmology, it happens that if you see a galaxy that is a long way from you, it takes all that time for the light to come here, and we can see them as it was in the past. So by looking at galaxies very, very far away from us, we can check that the universe in the past was expanding slower than we are. That was complete shock to all cosmologists because in basic relativity theory and in basic gravity, if you have an explosion and then the things are going away, well, gravity will tend to slow down the expansion of the universe and the motion of these galaxies. So everyone was expecting that now the universe should be expanding slower than it was in the past. When we found out that that didn't happen and we're going faster and faster, then we need a way to explain what is going on, what is making the universe go faster and faster, and that requires some kind of energy. Now, in general relativity, energy is a funny thing. It means everything that it's in this four-dimensional uh, play-doh, which we call space-time. And usually, again, it takes the form of matter, protons, electrons, neutrons. Another thing that is a topic for another video, which is dark matter, matter that it's not made of protons or electrons or the particles of the standard model of physics, but apparently something else entirely. But still, they all occupy some region of space-time and have attractive gravity, which is again the gravity that should slow things down. But in general relativity, you can fill the space-time with an energy that will have the opposite effect. If you fill the space with a complete uniform field of energy, then this will create a pressure that will make the space-time expand and create like a sort of repulsive energy. This is what is being called as dark energy. Now, okay, it's dark because we haven't seen it and we don't know what else is. And now the problem for theoretical physics is trying to figure out where did it come from? What is it made of? Is it a quantum field like the electron field or the Higgs boson field that somehow fills the whole of the universe? Then that will be some sort of ether, which is the idea that was that the universe was filled with this mysterious energetic ether in which light waves would move and wave, no? Being this was disproved by special relativity because we know that an electromagnetic theory because we know that light is a electromagnetic field and doesn't require an ether. But the idea is that it could still be a substance that fills all the universe and it's called quintessence, and this is one of the theories. Somehow we have to use quantum field theory to devise some sort of field that will fill the whole universe and have all the qualities we wanted. It must be uniform, it must not clump under gravity, it must provide this external pressure. And so far, it's very difficult to come up with a consistent feature. Oh, damn. Well, we're finishing here. I'll put the second part in my second